Aphasia is a language impairment that results from damage to the brain. The most common symptom of aphasia is difficulty finding or retrieving words, and it can influence many areas of language, like speaking, listening, reading, and writing. Aphasia is most commonly caused by a stroke, but it may also be the result of traumatic brain injury, neurological disease, seizures, brain tumors, or infections. Apraxia is a similar impairment that affects the muscle groups used in speaking and forming words. People with it know what they want to say, but there is an impairment between the brain and the oral motor systems, causing them to struggle to produce the sounds necessary to communicate. More people have aphasia or apraxia than have many other common conditions, including cerebral palsy, multiple sclerosis, Parkinson's disease, or muscular dystrophy. In fact, according to the National Aphasia Association, at least 2 million people in the United States of America currently struggle with aphasia or apraxia.
People with aphasia and apraxia can seek help from speech-language pathologists and perform therapy to improve their speaking ability. Both disabilities impair the ability to speak by making it difficult to produce words effectively, but their causes are markedly different. Aphasia impacts the ability to recall language, and apraxia impacts the ability to produce it. As a result, the therapy needed to treat aphasia differs from the therapy needed to treat apraxia. Unfortunately, it is difficult to distinguish the two of them from each other, and clinicians often do not make the distinction when diagnosing and treating patients. New research from the Brigham Young University Aphasia and Speech Learning Lab suggests that a new tool can be used to quantifiably distinguish between aphasia and apraxia. This new metric is called Word Syllable Duration, or WSD. It is a measure of how many milliseconds it takes to produce each syllable in a word on average. For example, if it takes a patient 1,000 milliseconds to say a 4-syllable word like constitution, then the WSD for that attempt is 250 milliseconds. Researchers at the BYU Aphasia and Speech Learning Lab have developed a test that consists of collecting and measuring the WSD of several attempts to produce multisyllabic words. The results of this test are strongly correlated with the severity of apraxia in the patient. Therefore, this test has two crucial uses. One, provide a data-driven and accurate diagnosis of apraxia versus aphasia, and two, quantifiably measure the severity of a patient's apraxia and track the effectiveness of therapy treatments. The test only takes a few minutes to administer, but calculating the WSD measurements is a lengthy manual process that can take a few hours. As a result, it is not feasible for clinicians to conduct this test on a regular basis.
A team of BYU undergraduate computer science students teamed up with researchers at the BASL lab to conquer this problem and improve speech disorder diagnosis and treatment for millions.
So the purpose of this project was to see if we could automate this word syllable duration measure so that it could be used clinically. Clinicians typically don't use these quantifiable metrics because it takes time to record and then put the recordings onto a computer and then go in manually and measure the duration and then get the word syllable duration metric. In order to make this more clinically feasible, this team has automated the word syllable duration measure as one metric that might be useful in diagnosing acquired apraxia of speech.
So the initial requirements included create a way to easily conduct a test of several multisyllabic words and quickly calculate WSD measurements. Provide an application that can be accessed by clinicians on their various mobile devices. Secure the application so that the patient and client data is HIPAA protected. Collect recordings and WSD calculations to gather additional data points for researchers at the BASL lab. And make a website where clinicians can upload previous recordings for evaluation and where researchers can view and download stored data. The most significant technical problem encountered during this project centers around the goal of providing access to as many clinicians and devices as possible. Due to our small team and strict time constraint, we wanted to limit the duplication of mobile app development. Rather than build two apps, one for iOS devices and one for Android devices, we decided that it was necessary to use a platform-agnostic framework. Unfortunately, the various platform-agnostic frameworks available do not contain tools advanced enough to perform the complicated sound analysis needed to calculate WSD measurements. We solved this problem in two ways. We built custom native packages, one for iOS and one for Android, that can calculate rough WSD measurements and can be utilized in an offline environment. And to provide more accurate measurements, we built a remote server to perform those calculations. However, recordings of a patient's voice is personally identifiable information and protected by HIPAA regulations. Therefore, secure communication between the server and the mobile app and storage on the server was a key focus. The research conducted at the BASL lab is new and groundbreaking in the industry. Consequently, there was no programmatic method of calculating WSD in existence. This required us to invent a way of performing this new calculation accurately and quickly. To accomplish this, we researched several different algorithms for extracting speech from a sound file. This was new territory, and we continually sought to improve these algorithms. With each iteration, we performed benchmark tests and compared our programmatic results to hand-calculated ones provided by BASL lab researchers to ensure a high and consistent degree of accuracy. Eventually, we developed a method of computing WSD that closely aligns with calculations collected through the manual process.
This is APPraxia. Clinicians can create a secure account, and after verifying their email via a secure link, they can sign in. If an internet connection is not available, a guest mode provides access to offline features. Repeated user studies found that clinicians initially looked for a how-to page so they can learn how to use the app. The how-to page contains detailed information about conducting and recording a test. The About page provides important background information, gives an explanation of research conducted by the BASL lab, outlines the terms of participating in the corresponding study, and details the app's HIPAA compliance. The Settings page allows access to 4 tabs. On the Account tab, clinicians can update their private account information. On the Prompts tab, clinicians can remove prompts that they don't like, add them back, or delete them altogether. They can also create their own custom prompts and record a verbal cue with it. On the Waivers tab, clinicians can invalidate waivers on behalf of patients who no longer wish to be included in the study. On the Evaluations tab, clinicians can view all of the evaluations they have previously recorded. The evaluation preview contains all recorded information about the test: ID, some demographic data, a timestamp, and a list of WSD measurements. Once a clinician has chosen to conduct a test, they can choose between local processing and advanced processing. The first step is to record the background noise in the setting where the evaluation is taking place. You can see the recorded waveform diagram and make sure that no abnormal spikes were recorded. For each word in the test, a page is presented. The word to be recorded can be seen at the top of the page, and a verbal prompt can be played for the patient to reproduce. The clinician can record multiple attempts in case the patient fails to produce the word on the first attempt. For each attempt, the recorded waveform diagram can be seen. Once the test is complete, the report page is shown to summarize the results. A clear breakdown of the WSD measurements by word and on average. You can play back the measured attempt
And if any attempt was invalid, you can mark it as unused and the average WSD will be recalculated. If desired, a button can be pressed that presents a diagnosis suggestion based on the average WSD. It also links to the research supporting this suggestion. The advanced processing test is very similar to the local processing test, but requires extra input for the enhanced WSD measurements. It uses a secure connection to our backend and stores the evaluation results for researchers to review. First, the patient must agree to a waiver to participate in the study and share the evaluation with researchers. If they've already filed one with his clinician, they can search for it by entering their name and email. If they haven't filed one, they can fill one out and digitally sign it. If a legal representative would like to fill out the waiver on behalf of the patient, they can list their relationship and sign it for them. A PDF copy of the waiver is kept on file and emailed to the patient and clinician. To provide some demographic data for researchers to analyze, a short survey is presented. If the patient does not want to provide this information, they can opt out of doing so. The recording of ambience and attempts on words is identical to the local test. The report page is similar to the one on the local test, but with one key difference. In addition to having WSD measurements calculated by more advanced processing, it also includes an option to email a PDF summary of the report to someone, like the clinician, for patient records.
To complement the mobile app, we also built a website with select features accessible. Clinicians can sign in or create a secure account using the same system as the mobile app. They can then upload previously recorded tests in a similar way to the format used in the mobile app. You simply upload the ambience and recording files. Then you fill out word information for each recording file. The results are clearly presented word by word on the subsequent report page. Researchers with administrator privileges have the ability to view recordings and evaluation results by time. This data is downloaded into a convenient CSV file, with or without the recording files, depending on their selection. In this project, we created a platform-agnostic app that securely and consistently calculates word syllable duration, a newly researched measurement to assist in data-driven diagnosis of speech disorders. We also produced a website that presents a form for processing recordings, as well as a portal for data gathering to enable further research in this area. Both of these systems are backed by an encrypted server running on AWS that allows for more precise computations and authorized data gathering to support research. Current plans will result in APPraxia later being available on the App Store and Play Store, allowing clinicians and researchers alike to leverage this new tool. Our product is the first application to provide a data-driven method of diagnosing apraxia of speech and distinguishing it from aphasia. It is secure, accurate, and easy to use. APPraxia will enable thousands to get the help they need.